So welcome back, my dear students. And till the last video, we have completed this process, which is on your screen. Work done in different thermodynamics process. In that case, for the adiabatic process, we have discovered the work done. This is for irreversible adiabatic process work, and this is for reversible. Okay, so yesterday I have discussed this completely. Now it is a lecture number 6, and today we are going to discuss about the first law of thermodynamics. So once again I am welcoming you. This side your chemistry mentor Govind Govind sir, and we are going to discuss about the first law of thermodynamics. First law of TD. So here we are having a first law of thermodynamics now. Check it properly. So what is first law, children? Sir, you tell me how I know. You have to know that it is a conservation of energy. That's it. Only this small definition. Yes, my dear, this is the first law. Conservation of energy. So first law of thermodynamics, one formula is also there. Delta U is equal to delta Q plus delta W. Yes, this is the formula for first law of thermodynamics. What is the values? Delta U, that you know, change in internal energy, IE. Delta Q is what, children? Heat given to the system, and delta U is what? Work done on the system. Work done on the system. Got it? So these are the things. For the small function, you can write du is equal to dq plus dw. If you are calculating for a small function, then this formula you have to use. So today the moment came which we want to discuss, internal energy. So focus on it. It's going to be very interesting. Here we are going to discuss about the internal energy. So think about it. And internal energy. What is internal energy? So before the internal energy, tell me one thing, children. For any system, okay, any moving system, what kind of energy it have? So total energy of any kind of system, majorly it is having kinetic energy. Kinetic energy, why? Because of motion. What I said, moving. It is having potential energy. Potential energy, why, children? Due to some gravitational or electrical field. Due to some gravitational and electrical field. How potential energy generated? Once again I am telling you, due to some gravitational force or electrical force. So these are the two major kind of energy in any system. One more kind is there, that is ionization, internal energy. Not these three only. In any system there are so many kind of energy. You cannot calculate, like sound energy, wave energy, light energy, atomic energy, so on, so on, so on. Okay. Suppose that system in rest, there is no motion in the system, and absence of external field. There is no external field applied and system is in rest. So here this energy will be 0, this energy will be 0. So now total energy is equal to internal energy. Yes or no? From the beginning onwards you have to pay attention. So now this I am erasing now. Okay, so total energy is internal energy. Now focus here. So internal energy means inside energy. So any molecule, suppose any molecule like oxygen. So oxygen molecules are attached, means in the oxygen atom. This is oxygen molecule, these are the oxygen molecule. So children, internal energy is equal to kinetic energy. Sir, here you said kinetic energy 0, system in rest, then why you are saying this again? Here we are talking about what, children? We are talking about molecule. Here we are talking about molecule. So in the case of molecule we are talking, so in the molecule, you know the gaseous system. So in the molecule what we are having? Kinetic energy. Not only kinetic energy, so many kinds of kinetic energy. Kinetic energy, transitional. Kinetic energy transitional for molecule, that you have to focus. We are not talking about system, we are talking about molecule. So here it is your molecule, so it is having transitional kinetic energy. Okay, understood. Then kinetic energy vibrational. It is also for the molecule. So molecule will vibrate like this. So kinetic energy vibrational. Kinetic energy rotational also. How, sir? Be with me, each and everything I will explain. So here this molecule rotate along the axis. These molecules rotate along the axis. They will rotate like this, like this, like this, like this. They will rotate. So rotational. It is not enough. Then it is having here plus potential energy. How potential energy, sir? Because this is the atom, and in the atom what you are having, children? In the atom nucleus having, electrons are rotating. So due to electron and nucleus, it is having potential energy. Got it? Potential energy due to these are the molecules. So here force is applied, force of attraction between the molecule. So potential energy for force of attraction. Here once again this molecule, force of attraction is there, and oxygen to oxygen double bond. So bond energy also there, bond energy plus so many kinds of energy is there. That is the total energy, internal energy. For what? For molecule. I explained kinetic energy, rotational, the molecule will rotate. Kinetic energy, vibrational, it will vibrate, zoom. It rotational, it will rotate. Huh? Then potential energy for nucleus and electron. So potential energy because of that, potential energy because of force of attraction, bond energy, and on so on. There are so many kinds of energy. Got it? Okay. Then next part, so children, internal energy internal energy. Now here so many kinds of energies are there. In the microscopic level you can measure, but generally you cannot measure. Yes or no? Because there are many kinds of energy present. So it is impossible to determine. It is impossible to determine internal energy of a system. It is impossible to determine internal energy of system. So that is not important for us. Not important. So what is important for us? For us, the important part is we will calculate change in internal energy, delta U. What we will calculate? Delta U. Change in internal energy. Change in internal energy we will calculate, because it depends upon the final and initial value. So from here, delta U is equal to delta Q, delta W we will apply. So children, understood the concept? That is the concept of internal energy. So let's talk about some property. So here, once again I am telling you, this is the graph, pressure versus volume, any point A to B, and again A to B. Here A, this point, and this point is B. This is one system, this is system number 2. For this, what is delta U? Delta U is equal to U final minus U initial. U final minus U initial. So here few property we are going to discuss. Check it. Number 1, property number 1, it is an extensive property. In the beginning also I told you, extensive property, because it depends upon the amount. System big, then more internal energy. System is small, less internal energy. Extensive is what? Properties which depends upon amount of matter. That already I have made a video. It is a state function. It is a state function. State function mean it's only depends upon the final and initial value, not path followed by them. In cyclic process, I told you all the in cyclic process all the state function will be 0. Got it? So internal energy formula, once again and again I am writing, children. Delta U is equal to delta Q plus delta W. Number 2 point, for ideal gas, delta U is equal to N CV delta T. This formula you have to apply. It is 100% correct, 100% true. Delta U is equal to NCV delta T. CV is what? Molar specific heat capacity at constant volume. For a small function, du is equal to NCV dt. Okay, it's 100% true. N is what? Number of moles. Remaining you know. CV how to find? Once again I am telling you, CV is equal to F by 2 plus multiplied R. R is what? R is equal to 8.314 joule mole Kelvin. In the calorie, it is approximately 2 calorie mole Kelvin. Okay, F value, degree of freedom, depends upon gas. Delta T, change in temperature. So these are the things understood. So why it's happening? Why this formula? Because children, if you remember, in the kinetic molecular theory of gas, internal energy is directly proportional to temperature. Internal energy for ideal gas only, internal energy is directly proportional to temperature. Internal energy directly proportional to temperature in the case of ideal gas. So this is all the explanation. Now I am erasing it and we will move for the next. So one question, why internal energy of gas, of ideal gas, is said to be only kinetic energy? Why internal energy of ideal gas is said to be only kinetic energy? So here listen it. Internal energy, all internal energy for ideal gas is equal to kinetic energy of its molecule. Okay, so kinetic energy of molecule means internal energy. How many kinds of kinetic energy? Kinetic energy transitional, kinetic energy vibrational, kinetic energy rotational. These kind of kinetic energy in the molecules having. Why I am saying this? because in that kinetic molecular theory of gases, I told you, not I, if because I have not prepared a video, sorry, but according to the kinetic molecular of theory of gases, there is no force of attraction, there is no force of attraction among molecule. Remember, in the kinetic molecular theory of gases, it said to that there is no force of attraction among the ideal gas molecule. If no force of attraction, then no potential energy. So internal energy is said to be only kinetic energy. Okay, so this is the explanation about the internal energy. Now we will discuss about the heat. Already we have discussed one video, number 3 is prepared for this, but once again a small introduction of heat. Delta Q is there because, so heat is what? Form of energy exchange, form of energy exchange, remember? Yes. So once again, heat given to the system, heat given to the system, if you are providing heat to the system, then its value will be positive. That means Q will be positive, Q will be positive. Then second, heat given by the system, it will be negative. If system is giving the heat, then it will be negative. So formula will be Q is equal to m c delta T. M is what? M is mass. C is what? Specific heat capacity. Delta T is what? Change in temperature. For all, for solid, liquid, gas. Okay, this formula for all. For ideal gas, Q is equal to NC delta T. C is what here? Capital C it is. Molar specific heat capacity. N is what? Number of mole remaining as it is. Okay, now sorry, work. Work done on the system. If work done on the system, then it will be positive. Work done by the system, then it will be negative. Okay, not I am going to again and again, I will not tell you formula. You know, W is equal to minus P external delta V. Video number 4 based upon this, you can check, or you can say W is equal to area under PV curve. So this is all about the first law. Okay, so here the time is almost 24 minutes, but still will complete it. We'll solve some problem. Question number 1. 500 calorie of heat is given to a system and system performs 350 calorie work. Calculate change in internal energy of system. Okay, so check it. 15 calorie heat given to the system and system performs 350 calorie work. So delta U is equal to delta Q delta W. So what? Delta Q, 500 calorie heat given to a system, heat given, then its value will be positive, plus system perform 350 calorie, so it will be negative. So answer will be plus 150 calorie. That is the internal energy. So here the language you have to focus, children. System performs, so work will be negative. Given to the system, then it is positive. Next question. Question number 2. 0.5 mole 0.5 mole of O2 is heated from 25 degrees Celsius to 125 degrees Celsius at constant pressure. Calculate Q, calculate delta U, calculate W. All these value we have to calculate. So formula Q is equal to NCP delta T. Why Cp? Because constant pressure. So number of moles 0.5 given, Cp is not given. So how to find Cp, children? Check it. Cv is equal to what? F by 2 R. That is the formula for Cp. Remember or not? It should be remembered. In that case, Cv is equal to, it is O2 is what? Diatomic. So F value 5 by 2 R. Okay, 5 by 2 R. R is what? In calorie, it is value is 2. So 2. So Cv is equal to 5. 2 and 2 cancel, then 5 only. Then Cp is equal to Cv plus R. So Cv 5, R 2, it will be 7. So put the value into 7. Sorry. So Cp value 7, not sorry, it's okay, into temperature 125 and 25, then 100, decimal 10. So Q is equal to plus 350 calorie. Good. Now delta U is equal to what? NCV delta T, all the time correct. Put the value. 0.5, CV is 5 into 100, decimal cancel, it is 250 calorie. Done. Now here W is equal to what? So first law, delta U, delta Q, delta W. Delta U 250, this is 350 plus delta W. So delta W is equal to minus 100 calorie. So delta W is equal to minus 100 calorie. It means work done by the system. Work done by the system. System is performing 100 calorie work. Got it? So these are the two questions. Now the third question. Question number 3. You will try it. Okay. So remaining question number 3rd, I will prepare one single video for the question point of view. So this is all about the first law of thermodynamics, which we have completed. So once again I am saying thank you, and this side your chemistry mentor Govind sir.